Hi everyone, and this is Francesco Vona, and together with me today there are also Jessica Barbieri and Mattia Gianotti and Alberto Patti. Unluckily, Professor Garzotto wasn't able to connect because she's got COVID, so she wasn't able to be here. As Irene already said, I'm a PhD student in computer science, and today I'm going to present you how we employed virtual and augmented reality to support autistic persons in urban mobility scenarios. We know that autism affects the way a person communicates, perceives, and interacts with the world. Autistic persons may present social interaction or communication deficits, restrictive behavior patterns, and overdeveloped sensory sensitivity. And this limitation in some cases impact the ability to independently manage daily activities, such as using public transportation or do shopping at the supermarket. Traditional intervention are not enough often because it doesn't exist a one-size-fits-all approach, and every autistic individual has unique strengths and challenges. Classical therapies are behavioral therapy, speech-language therapy, or play-based therapy. But in this context, routine is very important, and it's essential to create a program that is sustainable and ecological in the way it's structured. And this is not always possible, above all for the ecological context. So our solution, it's called 5A, and it's a project that we are carrying on since last year with 2 therapeutical centers specialized in autism. And the goal of the project is to support the training of autistic persons in completing everyday life scenarios that are characterized by complex social organizational conditions. This is an overview of the applications involved in 5A, and we have the virtual reality as a first step in which the user is trained in a simulated environment which is safe and controlled in terms of stimuli, while for the AR, it's used to train the user in a more ecological context, since it can offer support to the user while he is involved in the task execution in real life. In both the application, we can find a virtual conversational assistant that helps the user during the task and supports the user during the experience, providing stimuli, prompts, and voice feedbacks. This is the equipment that is required for 5A. We decided to use low-cost virtual reality approach. So the application will run on the smartphone of the user, and also the augmented reality will run on the smartphone of the user. The application are for Android devices. And in terms to experience also the virtual reality in the full way, the user has to use an head-mounted display with an external controller that can be connected through Bluetooth. As I said before, 5A is for autonomies in everyday context. So we are right now we are focusing on the public transportation scenarios, but we are also dealing with let's say social places like museums, or places like the supermarket for doing shopping. In the public transportation context, we have different scenarios. We have the subway, the train, and the bus. And in this presentation, we will see more in details how we develop the entire experience for the subway. We went through a co-design process in order to design both the applications, and we used the participatory design approach method. So everything from the beginning, from the requirements elicitation to the final prototype testing was done together with stakeholders, and in particular, we collaborate with the therapists of the two therapeutical centers. We schedule 6 focus group and workshops, and then we will see the results of this focus group. In these meetings, we use proxies in order to facilitate the work of the therapists. This is the first focus group that we have done, and it was about the virtual reality experience. The goal of these meetings were to design the task flow of the user experience, the interaction paradigm for the virtual reality application, and the role of the conversational agent in terms of conversations and in terms of behavior. For this meeting, we use sticky notes as a proxies, and we use different color for a different meaning of the experience. Like, for example, the green sticky note was for events that have to happen in virtual reality, while the yellow sticky note for the conversation with the virtual assistant. And this gives the therapist the possibility also to change at the last time the order of the execution of the task or the conversation after the discussion with all the group. For what concerned the AR experience instead, we had another kind of problem. We keep the same UX flow of the virtual reality experience, but since the augmented reality merge real contents and virtual contents, we want to find a way which was usable for autistic individual and was easy to understand. So we give the therapist transparent sheets on top of photo of realistic subway scenarios, and the therapist has to draw on top of these transparent sheets how they imagine the user interface or the interaction with the user. At the end of this focus group, the complete task flow was made of 6 activities, from find the entrance of the subway. The second one was buying a ticket at the ticket machine, interact with the turnstile, identify the correct direction of the train, reach the subway platform, and exit to the right stop. What is different in this task, which are common both in virtual and augmented reality, is the way we organize the subtask, because each of these tasks has different subtasks depending on the technology that we are using. For the virtual reality, for example, the user will have to watch the turnstile, in case of the turnstile, watch the turnstile, select the turnstile, and then move towards the turnstile. And we associate to each of these subtasks a basic interaction in virtual reality. So the watch the turnstile as a subtask is a simple gaze interaction that the user will have to do. And the select the turnstile will be a selection interaction. And we will see more in detail these 3 interactions, which are basically the fundamental interaction in virtual reality. For the gaze part, the user will have to look at a particular point, putting this white dot on the target for just 3 seconds. So in this case, the target was the metro sign, and the user will stare at it for 3 seconds. The second interaction was the selection. And for the selection, the user has to look at an object and then press this button on the controller in order to confirm the selection. And here we cannot see the user pressing the button, but after he's watching at a ticket machine, he presses this button and select the ticket machine. And then there is the last interaction, which is the move interaction, in which the user has to move in virtual reality. And we adopt a continuous movement approach, so the user will experience the movement along the virtual reality environment. And to do so, the user has to look at one direction and keep press this button on the controller. If the user leave the button, he will stop. in the position where he is. Okay, so for the AR part, instead, we have to merge both the what happened in the virtual world and what happened in the real world, the virtual part and the real part. In case, let's keep the same example, so the turnstile, and in this case, the user will have to scan the turnstile in order to inform the system that the user has arrived in front of a turnstile, and then the system will give the next prompt to the user. So here, the dashed diagrams here are for the real life task. So there are some action that the user has to do in the real life, like for example, insert the ticket in the turnstile, and other actions that the user has to do for the augmented reality application, which are, for example, scan the turnstile. Here, the main two interactions that we highlight are the object image recognition and the vocal interaction with the conversational assistant. For the image recognition, the user has to scan a particular object that can be the ticket machine, the turnstile, or any other key object in the experience. And this is, for example, the case of the ticket machine. So the system will recognize the ticket machine, ask the user if the user already have a ticket, and in case the user answer no, an arrow will point the ticket machine, suggesting the user to interact with the ticket machine. The second interaction, as said, is the vocal interaction, and since some autistic users or cannot speak or doesn't want to speak, or the environment in which the application is running is the subway, so it can be a noisy environment. We also allow the user to interact with buttons in the UI. So the answer in this case can be click on the button, say yes, for example, or just pressing this button on the side with the microphone to register a message. And it was mentioned a lot during this presentation. One of the main elements of the applications is the virtual conversational assistant. We integrated in both the application, and in the virtual reality experience is active and it's present with the user. So the user will move, the assistant will move together with the user. While for the augmented reality part, we decided to integrate the assistant in the 2D UI to avoid that the assistant will disappear behind walls or behind the real environment. And at any time, the assistant can offer support to the user and can receive requests from the user. And this can be done because we designed all the experience with our final state machines. And inside every state of the final state machine, we put together what the assistant has to tell the user and something that can happen in virtual reality or in augmented reality. So the assistant will be always present in every moment of the activity. And we categorized what the user can tell, so what the user can understand and what the assistant can tell. And in this case, the communication intent are sentences that the assistant can recognize and that the user can tell. So for example, the user can ask for help, can ask for a repeat the task, so what he has to do, or can answer in an affirmative way or in a negative way to an assistant question. While this is what the assistant will ask to the user, will tell to the user. So he will tell, for example, to select something or to be careful because maybe the user is selecting the wrong object. Or in case of the user cannot complete a task, he will give a reinforcement to the user. As said before, the assistant is common to both the application. So it's we call this element a transmedia element. So both the virtual and augmented reality. In both the virtual and augmented reality, the user can find the virtual assistant, but there are also other elements which are common. And we use these elements to create a continuum between the two experiences. So the user can find in the virtual and in augmented reality the same elements, and this can help the user in understanding what he has to do and in doing the task correctly once in the real world. And the second element are the interacting objects. So we have particular attention for some elements, like for example, the ticket machine, the turnstile, or the direction of the train that has to be taken by the user. And these elements are common in the virtual reality and in the augmented reality applications. And then there are also attractors that are used in order to point particular interacting objects or elements that the user has to interact with. In the end, we are designing an on-the-field study, and the goal of this study is to measure the effectiveness of 5A in helping autistic people learn how to take public transportation. And we are focusing on the subway scenarios and on the train scenarios. What we want to explore is if the applications are usable, both the virtual and the augmented reality, and if 5A can be an effective support for therapeutic treatment for improving the autonomy of autistic people, and if 5A can be adopted by therapists during their daily work. These are the inclusion and exclusion criteria for the user profile that we are going to involve, and we are recruiting more or less 40 users from the 2 therapeutical centers. And this, in the end, is the protocol that we are going to execute. So we will have 3 test moments and a total of 13 sessions, 10 for the virtual reality and 3 for the augmented reality application. Thank you for your attention, and thanks to all the people who work in this research.